Hello everyone, welcome to our video on graphing lines. So there are three ways to graph lines. Some are more advantageous depending on the way that it's set up. So for instance, these first two, it's usually easiest to do the slope-intercept form. Okay, so let's break that down. Let's go ahead and do that method. Okay, so to use the slope-intercept form, so these are both in slope-intercept form, we're just going to say, well, this is our slope of 2. And remember, that can also be written as 2 over 1, which shows us our rise and run. And then this value right here, including the sign, is our Y-intercept. So that's helping us with the Y-intercept, and I'm creating it as a point. Sometimes they might write it like just like this: Y-intercept, y equals -1. However, sometimes that can be misleading because this is y equals -1 is technically a line. Okay, so but still, depending on the format, that's how they might do it. So I usually like to write it as a point to really make sure that it is truly just a point. Okay, anyway, so we'd have them, and what we'll do is we first graph this. So graph the y-intercept first. And then afterwards, we'll use the slope. So to break that down, let's go ahead and we'll make our own graph up. Sometimes it's on its own grid, you know, and it's nice, and we can make it real accurate. But here's our x-axis, here's our y-axis. Okay, so we'll graph our y-intercept. So let's go ahead and go 1, 2, 3, 1, 2, 3, 1, 2, 3 each way. 1, 2, 3. Okay, so our y-intercept is 0 and -1. So that means go down 1. So we're right here. And then we'll use our slope from this point. So we'll go up 2 from the point. So 1, 2, and then over 1 to the right. Okay, so to show that in blue, so 1, 2 up, and then run 1 to the right. And then that's our new point. Or that's not our new point. That's our second point that's on the line. Okay, so we've got, let's just make that bigger. There we go. Okay, and if it is on a very nice grid, we can label these points. So 0 and -1, and then this looks like it is 1, 1 as that point. Okay, so that's a way to break down these problems real quickly. Now, to kind of double check, what you can also do with the table method is plug in some values for x. So for instance, if we plug x equals 0 in, our y is the equation 2x minus 1. So if we plug 0 into that x, we would get -1, which is that first point. If we plug 1 in, 2 times 1 is 1, minus 1, just to show the work. It should have done that there too. Okay, so that's where that -1 comes from. So this is just scratch work. 2 times 1 is 2, minus 1 is 1, and that's that point. And then one last one, if you plug 2 in, 2 times 2 is 4, minus 1 would be 3. So that would be up 2 to the right and then up 3, which looks like it is sort of accurate on ours as well. But all you do need is 2 points to graph any line. So getting others, though, is kind of nice to verify that it is correct. Okay, so that's using the table. So in the table, we make up our own x values, and you could keep going. You can make more up. You could do negatives as needed, or even fractions. Okay, so it's entirely up to you. All right, well, let's look at this number 2 and use our same method with our slope-intercept. So we have the slope is -2/3, so it's whatever's attached to the x, and then our y-intercept +4, so I'm going to write it as 0, 4 over there. Okay, and let's go ahead and get our grid going. And on this one, I think hopefully 5 each way is going to be good. Okay, so there we go, and that's our that's our y-axis, and here's our x-axis. Okay, so we've got our grid ready, and just like before, well, again, start with graphing the points. So 0, 4 would be up 4. There we go. Now, with our rise and run, with this one, it was positive, so that means you do rise up and run to the right. Remember, and you could always check anyways afterwards, so positive slope should go up from left to right. So the rise is up, the run is right. With negative, the rise is going to be down. The 3, though, the run is still going to be right, because that will make it go down from left to right. So, and again, just verify with your picture at the end. So let's go down 2 from this point. So 1, 2 down. Actually, let me show it in the blue. So down 2, and then we'll run 3. So 1, 2, 3 right there. So this in the blue is not part of the graph, just doing it for the visual. And that gives us our point. So down 2, right 3, and then now we connect these the best we can. It's a little tough sometimes on the computer, but those are our points. So there's 0, 4. And then if I graph this right, it looks like it's 3, 2. 3, 2. And if we could always double check and it would work out, or we could make the table. So 0, 1, 2, 3. Here's where the table can be a little tricky, because like the 1 and 2 value, you'd have fractions involved. Okay, but if you do use 0, you would get 4, and if we did plug in 3, we would get 2. It would match, and there we go. Okay, so notice 1 and 2, again, if you do plug that in, so just plugging in 1 and 2 into that x, you would have a fraction to deal with, so those aren't very good ones to work with. If you did plug in another point, a good point would be like 6, because 6 would reduce with that 3 in that denominator. Okay, but anyway, I'm going to stop at that. Well, for this problem with our line, we've got it. We've got the points. Everything is done. Okay, these other two. So these other two are in a different form. So they're not in slope-intercept form. So if it's in slope-intercept form, it's usually pretty much the fastest way to graph it the way that we did it right there. Let's go ahead and find the intercepts in this method. So to find the intercepts, and they might want that anyway for other problems, it's still kind of making a table, but what we're going to do are, we're going to use 0. So we're going to just plug in x is 0, and we're going to plug y in for 0. So if we plug x equals 0 in, we plug it into our equation. So 6 times 0 minus 2y equals 20. And then 6 times 0 is 0. So this really is just negative 2y equals 20. And then if we divide by negative 2, so I'm just going to show that to the side, that would be, whoop, I freaked out. That would be y equals negative 10. So 20 divided by 2. So that means when x is 0, y is negative 10. And then we'll do it similar with this 0 for y. If we plug 0 in for y, we would get 6x minus 2 times 0 equals 20. Well, 2 times 0 is 0, so this really is just 6x equals 20. We divide both of those by 6. Since this one isn't as nice, I'll show it in the blue underneath. Well, 20 divided by 6 would give us 10 over 3. Or if, again, we're allowed to use calculators, it would be 3.3 with the 3 getting repeated. Okay, so that can help with finding it on our graph. Okay, so anyway, so I'm going to do 10/3 though as a fraction still. So those are our intercepts. So our let's actually label, so the x-intercept is the one that has an x value besides 0. So that is the 10/3 comma 0. The y-intercept is the 0, negative 10. So I using this table, be careful when actually writing out those intercepts. All right, so we've got our x and y intercepts, and the way that we can go from here with our picture. Okay, so negative 10, so our scale is going to be a little smaller. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so something like this. There we go. All right, and then what we've got, so the x-intercept is about 3.3 and then 0. So we'll count over 3, and it's somewhere between 3 and 4, so it's going to be a little tough to see. Let me actually just do it in a different color. So it's in between 3 and 4, so I'm just doing it slightly right of 3. And then the 0 and negative 10, okay, so that is right on a tick mark. There we go. And then now all I have to do is connect the dots. And there it is. Okay, so there's the 0, negative 10, and then there's the 10/3 and 0. Okay, so that's using the intercepts. So those are our 2 points, and we've got it. Okay, and that from there, or with this, again, we could check it with different ways. For instance, if we wanted to double check using the slope-intercept form, we could rewrite this if we really wanted to, and then do what we did in the previous problem. So just real quick, we could subtract the 6x over, and then we could divide everything by -2, which would give us this equation. So y would be 3x minus 10, which does have the y-intercept of 0, -10. So that's a match for that 1 point down below. But we'd have to do it a different way with our slope. The slope is 3 over 1. So from here, I would have had to gone up 3. So 1, 2, 3, and then over 1. Notice on our picture, it looks like it is matching. Okay, so even with a not perfectly drawn XY axis, we can still kind of see that it works. Okay, and well, if we had gone up 3 and over 1 to the right, it would be 1 and -7. So that gives us a point that doesn't have a fraction in it if needed. Okay, so anyway, so that's doing the slope-intercept. That's double checking. So we could really verify we have 3 different methods we could use. So if you're ever unsure, or say it's a test and you got plenty of time, definitely do more than one method. All right, for number 4, it's not really in any form that's great right now, but it looks like it would be pretty easy to get it in slope-intercept. So I'm going to convert this into slope-intercept form. First thing I'm going to do to make that happen is just rearrange the right side, because we usually like to have the x term first. So we have 9y equals -3x plus 12, and then now we can divide by 9 to get y all by itself. So we've got y equals -1/3 x plus, okay, so 3 divided each of those, and then this also reduces 3 divides each of those as well, which would give us 4/3. Okay, so this is our equation in slope-intercept form. Okay, and then now we just need to find we just need to plot it. So we've got our y-intercept. Let's go to mark that. That's our y-intercept, 0 and +4/3. And then our slope is -1/3. Remember, it's negative, so that would be down and right. Okay, so it's 0 and 4/3. Okay, so let's go ahead and do 1. Let's make this a little bigger. 2, 3. And then 1, 2, 3. 1, 2, 3. 1, 2, 3. So I'm hoping this is big enough. Okay, so 0 and 4/3. And again, if you can use a calculator, I mean, feel free to. This is 1.3 repeated. So that means we would go up 1, and actually let me do it in a different color too to mark it. So up 1 and a little bit past 1. So we're about there. Now, if we're doing this by hand, using our slope, we just have to really make sure we're in the right spot. So if I go down 1, I would be about here. So that's a length of 1. So going down 1, and then right 3. Well, that I can see right here. 1, 2, 3 puts me slightly above the x-axis. And I can now draw in the rest of the line. Okay, so let's mark our point. So this was the 0 and 4/3. There's our down 1 and over 3, just to mark it our slope. Okay, and then if I want this point, well, we can definitely see the x-coordinate is 3. And then if I need the exact y-coordinate, well, I'm thinking I went down 1 from 4/3. So that would be just subtracting 1 from the 4/3. And we can get a common denominator. And eventually we can get 1/3. Okay, so down 1 from 4/3 is 1/3. Our right 3 is that 3. So there's our points in case they need the actual points along with the graph. Okay, so if it's not just a quick sketch, if they want those points with it, we've got them. Okay, but anyway, and then on this problem again, if you want to check it, you could do you can find the y-intercept and the x-intercept. You could do the table. So there's 2 other ways to verify this problem. But that's going to be it for now. If you do have any questions, please let me know. Otherwise, thanks for watching, and I'll see you again.